Hello friends, today we will be talking about the morphology of gastropods. As you all know that the gastropods are all mollusks. So, the primary feature of the phylum Mollusca is the presence of a calcareous exoskeleton. As you can see from many of the forms I will show you here that the exoskeleton is made up of the calcareous material. Most of the time it is calcite, sometimes it is aragonite also. Hence, this satisfies all the gastropods as belonging to the phylum Mollusca. These gastropods are single shelled, they do not have two-piece walls as in case of the lamellibranchs as we have seen in the previous lecture. So, in this lecture we will be talking about the morphological features to be noted down by any geologist if he finds the shell of a gastropod. So, before I begin to describe them in detail, the morphological features in detail, I will suggest you to have a paper and a pencil or a pen, so that you can note down the features to be analyzed. The first thing one should note down when he or she gets the shell of a gastropod is the form of the shell. That is the point number 1 to be noted. The form of the shell, that means the form of the shell should include the size. Size means, like for example, if you get the shell of almost this size, so this is said to be little larger, and when you get the shells of these sizes, this is said to be little smaller. Always note down that these smaller and larger sizes, these are all relative. If you get the shells of these size, you can say that the size is medium. So, you can divide the size into the large, medium and small. Then comes the shape of the shell. Shape is basically a very primary geometrical term. So, in gastropods, these terms includes the discoidal forms. As you can see, this particular gastropod is a disc shaped or the discoidal forms. It is usually found in one plane. This is discoidal. You may be remembering cone. Cone also is a geometrical feature. So, you can see this gastropod that is conical in shape. Sometimes the gastropods are also biconical. As you can see, you can have a cone on this side and a cone on this side. So, you can have the same form, like for example, this is conus. So, conus is both conical as well as biconical. So, we have discussed two of the primary geometrical features, discoidal forms like this, conical this and biconical this form. Then comes the fusiform. Fusiform gastropods can look like this, tapering broad at one end, whereas tapering at the other end. So, these forms are called as fusiform. Here I am holding the shell of a murex. You can write the shape of the murex as fusiform. You can write the shape of the fusinus also as fusiform. Maybe the etymology or the name by which the fusinus is known is because of its primary shape, that is the fusiform shape. Then after which comes the spindle shape, like you see it is thickest in the middle, whereas it flares and thins on the margins. So, this is basically the spindle shape. You can also have pupae-form. So, this is a gastropod which is called as oliva, and this is pupae-form that resembles the insect pupa. Then you have trochiform. This gastropod is trochus. So, trochiform is like a top. In the childhood you may have played with the top. So, the gastropods that resembles the shape of the top, they are called as trochiform. So, and then you have globular form as well, like Cypria. Cypria is a gastropod which you can say it is a globular form. So, you have seen many different forms like this. This is called as turreted form, turiform or turreted. So, this shape is called as turreted and the example is Turritella. So, you have seen many shapes of the gastropods: discoidal, conical, biconical, trochiform, fusiform, spindle shape, turreted. Then the next aspect to be studied in a gastropod after the form of shell is the coiling. Coiling has many aspects, Coiling, first, that is either the coiling is in one plane that is two dimensional. So, if the coiling is in one plane, that is called as planispiral coiling. This particular form planorbis is named because of its planispiral coiling. Then comes the conispiral coiling or trochospiral coiling. So, as you can see the other forms like this, this is not planispiral, the coiling takes the horizontal plane as well as in the vertical plane also. So, this is called as trochospiral. Here also you have trochospiral coiling, then also in this you have trochospiral coiling. So, as far as the planispiral coiling is concerned, you may have this form which is discoidal. This also looks like conispiral, but this is in the one plane. The form of the shell is spindle, but it is planispiral coiling, and the form of shell is discoidal, but also it is planispiral coiling. The other shells, as I have shown you, they are all trochospiral. The best example of the trochospiral coiling is the trochus. As you can see, the coiling is in the horizontal as well as in the vertical plane. So, you may have the high trochospiral, low trochospiral coiling also. After this, you have another aspect in the coiling, and that is the sense of coiling or the direction of the coiling. As far as the direction is concerned, we will begin with the, you may be seeing a spiral shape here. So, if we start from the center, from the very beginning, and we move like this, then as you may be observing, my pencil tip is moving in the clockwise direction, and if the coiling is clockwise, it is said to be dextral. Most of the gastropods are having dextral coiling, but there is one gastropod which is called as Physa, which I will show you here. This is the fossil of Physa, and this will show sinistral coiling. As you can see that my pencil tip is moving in the anti-clockwise direction. So, this particular form shows anti-clockwise coiling. So, this is a sinistral form. Physa is a sinistral form, rest all of them they are dextral form, they show the dextral coiling. Here the coiling is in either one plane, that is planispiral, or if it takes the vertical plane also into account, it becomes the trochospiral. And in the plani and the trochospiral form, you may have dextral, that is clockwise coiling, and sinistral, that is anti-clockwise coiling. There is one more special kind of coiling which is called as convolute coiling. Convolute means from both the sides. The best example for the convolute coiling is Cypria. Cypria in Hindi is also called as Kaudi. Earlier this was said to be a kind of an ornament also and kind of a currency as well. I have cut it down a transverse section of one of the shells of the Cypria just to show you that the coiling is from both the sides, because of which, see, this part is also coiled and this part is also coiled. This is more coiled, this is less coiled, but both the portions, both the ends have coiled, and because of which this is called as the convolute coiling. This is considered to be the most modern sense of coiling in the gastropods. So, we have discussed two basic geometries, two basic traits or two basic characters to be noted down by any observer if he or she gets the shell of the gastropod, like the form of the shell and the coiling. After the form of the shell and coiling, the first thing, the next thing rather to be discussed by any person is the spire. What is a spire? Actually, let me show you by some example. As you can see, the animal is coiled. This is one example of a coiled animal. This is another example. These are all exoskeletons. The animal, the soft part has been taken away. So, you may be seeing that all of them are coiled, and if the coiling starts from here, that means this has to be, and it propagates in this direction, that means this has to be the last coil. So, this last coil is called as body wall. The earlier ones are called as spire and the last coil is called as body wall. So, this spire and body wall ratio is very specific to identify a particular gastropod. Like for example, if I show you this form which is called as Turritella, here you would see that spire is very long and body wall is very short. Compared to the body wall, spire is much larger. So, what anyone must do is to find out the ratio of the spire and the body wall, and this is a very important characteristic feature to be mentioned, to be identified, to be used in the identification of a gastropod. Like the other way, if I will show you, here you see the spire is very short and the body wall is very large. So, you have in different gastropods the different proportions of the spire to the body wall. Let me remind you again that body wall happens to be the last wall. So, in order to find out the correct proportion or the correct spire to body wall ratio, you have to first differentiate yourself that what I am looking is a body wall and what I am looking is a spire. Like for example, if you see here, this particular shelf, over this particular shelf, you have the spire. So, this is earlier walls or the spire. This is the last wall which is called as the body wall. And as you differentiate yourself between the spire and the body wall, it will be easier for you to find out the right proportion. The next thing one can use in this spire character is to find out the apical angle. And what is apical angle? Apical angle is very easy to measure once you differentiate spire and body wall. This is a particular surface because this is a cone. So, from this point this is going this way, whereas from this point this is going in this way. So, you have to take a pencil like this and a pencil like this. So, wherever these two would converge, this acute angle that these two tangents are 10 at this point is the apical angle. This apical angle may be acute, this apical angle may be intermediate and this apical angle may be obtuse. Here in the Turritella, it is the acute, whereas if you see the apical angle in Natica, which is having very short spire, then you would get an obtuse angle. You see, this is one tangent and this is the other. So, this will be having an obtuse angle. So, you can have an acute apical angle, you can have an obtuse apical angle. Also, you may have cases when you can have the intermediate apical angles also. Then, after the spire, the next point to be noted, to be observed, to be analyzed is the suture. Suture is very simple to be described. It is of only two kinds. It can be observed under only two kinds, horizontal and inclined. As you can see, the suture here is horizontal. You can also see here the suture is is almost horizontal, and then if you see trochus, it is little bit inclined. You can see the territella, you have an inclined suture. So, you can have the inclined as well as the horizontal suture. Then the next character is the axial character. Axial character, to show you the axial character, I have taken a longitudinal section of a particular gastropod. You can see this is the axis of coiling. This axis of coiling is called as the columella. Columella is vertical stout axis around which the particular gastropod coils. Sometimes this is a stout, so the gastropods would be called as imperforate, whereas in some forms, as you can see here, this is hollow and this is formed by the folding of this inner lip. This is the apertural margin, of which this is the outer lip, this is the inner lip. So, the inner lip folds and you get an hollow space, and this hollow space is called as columella. So, if you have the columella with a hollow space, the gastropod would be called as perforate, whereas if you have this stout axis, then the gastropod would be called as imperforate. So, when you have the hollow space, it is perforate. The best example of the perforate gastropod is the Natica, whereas the others are imperforate. After axial character and the suture, we will be coming to the next character to be mentioned by any paleontologist about any kind of the gastropod, is the aperture. If you see apertures, apertures are of different shapes. This aperture is it is broad at one end and it narrows down at the other end. Some of the apertures, they have uniform thickness throughout, and the length of the aperture is as long as the shell. So, you have this narrow aperture as long as the shell. You have the aperture which slightly becomes broader at one end, narrower at the other. You have aperture which is sub-rounded. You may have aperture that are somewhat rounded. You may have apertures which are slit like, you can see, and some of them they have the crenulated lip also. So, you can have apertures with the crenulated lip. You can have apertures which are exactly semicircular or semi-lunar. As you can see, this is a D-shaped semicircular aperture in Natica. So, you may have apertures of different shapes and sizes. So, this is one aspect to be mentioned. The other thing which one can study about the gastropods, apart from the features I have mentioned so far, is the ornamentation. Some of the gastropods, like this is Cypria tigris. This is having this spot and the variously colored surface. So, this is one kind of the ornamentation. The other kinds of the ornamentation, as you can see, is the terrated form of the territella with spiral bands here. You may have the vertical costae. So, you can have costate ornamentation. You may have the pearly surface. So, enameled, the surface may be enameled. Some of the forms, they may show spines or tubercles. So, you can have tubercular ornamentation. So, as you have seen and as I have told you, that there are so many features to be mentioned. Form of the shell. In the form of the shell, I mean to say the shape of the shell. Coiling can be dextral, sinistral, convolute, planispiral, trochospiral, high trochospiral, low trochospiral. Then we had the suture may be horizontal, the suture may be inclined. Then we can have the aperture can be of different shape. Axial character, you may have either the stout axis, or you may have the hollow columella. So, if you have the hollow columella or umbilicus, which is formed by the inner folding of the inner lip of the aperture, then you can have the perforated gastropods. You have different features to be mentioned. You may have the gastropods with different ornamentation. Some of them, like Teratella, may have spiral bands. You may have the spines or knobs. You may have differently colored, or you may have the very smooth surface. Then one of the very important features that one can mention into the gastropod study is the apical angle, measurement of the apical angle. It can be either acute, intermediate, or obtuse. The apical angle, apart from the apical angle, you can have the ratio of the spire to the body wall. Some of the gastropods may have long spire, short body wall, like Teratella. Some of these gastropods can have short spire and the large body wall, like in Natica. So, you have different kinds of the morphologies. Apart from that, you can then comes the name. After so many morphological characters that you observe, then the thing which you arrive at is the name or the nomenclature of the gastropod. Finally, you have to write the age of that particular gastropod. Like for example, you have the trochus that ranges from Triassic to recent. Then you have Teratella, this ranges from Cretaceous to recent. Then you have Murex, it ranges from Eocene to recent. Exactly in the similar way, you can have Oliva, that also ranges from Eocene to recent. Then you have the Fusinus, that is Cretaceous to recent. You can have different gastropods ranging in age from different age to different age. The thing about the gastropod which the paleontologists find itself difficult to study is that the classification of the gastropods is based primarily on the soft part of the organism. But you see, in geological record, we get only hard parts as fossils. So, for a paleontologist, the greatest difficulty is that we have only hard parts before us to observe. Therefore, the basic biological classification of the gastropod, it is very difficult to incorporate straightforward to the fossils. I hope you have enjoyed and learned how to describe the morphology of the gastropods, and we will be discussing about the morphological features of the other paleontological groups as well in the coming lectures. Till then,